In this video, we will review ILM150104i Objective 1 Threaded Fasteners. Fasteners and locking devices. Objective 1 Threaded Fasteners. At the start of the Industrial Revolution, each machine shop made its own nuts and bolts. Each shop had a different design, and a nut from one shop would not fit a bolt from another. The impracticality, high cost, and inconvenience of this method is why fasteners have become standardized. Objectives describe threaded fasteners. We are not going to do all of Objective 1. We aren't going to get into the full description of threaded fasteners and their applications or non-threaded fasteners and their applications. All we want to learn is how they are called out on blueprints. So this describes what threaded fasteners are. The callouts we're going to be looking at for our drawings are for screws. So a screw is inserted into a threaded hole in a part. Machine bolts, a fastener that has a hexagon or square head, allowing it to be tightened with a wrench. Machine screws, they're smaller than machine bolts, rarely more than 1/4 inch in diameter, and they have a driving recess on the head. When we talk about driving recesses, Figure 4 shows a bunch of them. Allen, Robertson, Slotted, and Phillips are the most common. Figure 5 talks about head styles for machine screws. Most applications are either round, flat, or oval. Cap screws have a tighter tolerance than machine screws. Set screws also have a call out for threading. And studs are threaded on both ends. Self-threading screws, thread forming screws, and thread cutting screws have thread call out designations, and as do nuts, Figure 11. So this is what we want to look at, is how threaded fasteners are called out on our drawings, the notes that you will see. So we can have fasteners that are imperial or metric. So let's look at the imperial thread designations to start. So this is an example of a thread call out. So Figure 12, we have a 4-inch long screw, and it's called out as 1/2-13 UNC. So let's figure out what that means, what this call out means. So your first number is your nominal thread size. Second, we have threads per inch. We have a thread form, UNC. You'll see UNC, UNF. So that's, UN. And then separately, you could see C or F for coarse or fine or extra fine. We have the length. And pay attention to what kind of a screw it is that you're measuring, what kind of a fastener, whether it's going to be from under the head or from at the top of the head. We have the product name, we have the material, and any finish that is required. So that's for imperial. So metric, Figure 16 shows us symmetric fasteners. Symmetric is called out a little bit differently. Our product name comes first, M for metric. Then we have our nominal diameter. We have our pitch, our length. We could have our steel property class or material identification, and any protective coating that's required. Then it talks about nuts and bolts. So we said that nuts and bolts are also threaded and have callouts. So that's all we want to talk about in objective number 1 for threaded fasteners, is to learn how these thread designations are called out. When you go back to your lesson in SAM, we have more information there for you. We have exercises and some online interactive things. So once you've completed this, go back to your lesson in SAM, please. That concludes our review of ILM 150104i, Objective 1, Threaded Fasteners.